Chapter 3, problem number 48. And this one is a good and not good problem, but we can learn, right? We can learn from this. So the question says, prove that the trajectory for projectile motion is also a parabola. And, we draw these projectile motions like this all the time. We say, oh, look, there it goes. Launch at some angle. It's a parabola, right? Or, as you might like to say, a parabola. You can call it whatever you want. I'm fine with either way. Well, let's just go ahead and do it, and then I want to talk about position versus time graphs versus position graphs, because I think it'll be useful. So let's show that the trajectory equation, the path that it travels, is a parabola. And so that would be a plot of, I want to show that a plot of y versus x is a parabola. Well, we know that these are our two kinematic equations that we really want to deal with if we start from the origin. So if we start from the origin, x0, 0, y0, 0, that problem actually says to do that, and that's fine. So let's take this equation and solve for t. We don't want t, right? We want to plot y versus x. There's no t's in there. So if I solve that for t, I get t equals x over vx0. And now I'm just going to plug that into this equation, and I get y equals vy0 t, which is x over vx0. Right? All I do is substitute in the t, and then I have minus 1/2 g t squared, which is going to be x squared over vx0 squared. So is that a parabola? Well, yeah, right? Because the equation for a parabola looks like this. Y equals ax plus bx squared, where a and b are constants. So do we have it in that form? We do. Let's just rewrite this. Y equals, I'm going to put the constant together. This is vy, that is y, y0 over vx0 times x. Let's say plus negative g over 2 vx0 squared x squared. So that's my a term, that's my b term, so it is a parabola. Now let's just double check right here, okay? Because if this is a parabola equation, the units should work out too. The units for y are in meters, so each of these terms has to be in meters. So I know that x is in meters, and here I have meters per second divided by meters per second, which is just no units, so that whole term is meters. That's good. Okay, what about this? Here I have meters squared. So this term has to be in 1 over meters. So here I have meters per second squared. Here I have meters squared per second squared. So the second squareds cancel, and I have meters over meters squared, which is 1 over meters. That also works. Okay, so the units all work out okay, and the plot of the trajectory is indeed a parabola. So now we actually have 3 graphs that we could consider. Let's just draw those 3 graphs for projectile motion. Let's write down those 3 equations. I'm going to say x equals, I'll write it as x0 more generically, vx0t, y equals y0 plus vy0t minus 1/2 gt squared, that's a half. And then I had this one, I was putting this, y equals ax plus bx squared. We just found a and b, I'm not going to rewrite those. So all these involve 2 variables, so I can make a graph. This one I can make a graph of x as a function of time. And you can see right here, that's my variable, constant t. So this is a line. This looks exactly like a line, right? This is the equation of a straight line. Remember, the equation of a straight line is y is mx plus b. So this says that x0 is the y-intercept, and m is the velocity. So let's just write that graph. It'll look like this. I'll do it generically. So this is x as a function of t. This point right here is x0, and the slope is equal to vx0, the velocity. Now, what about this? Here we have a parabola. Now, this one's a little bit more difficult to show, but it is a parabola. It's a parabola that looks like this. Y as a function of t. Again, this you can put in, say what at t equals 0, which is right here. You can see that that has to be y0. So this is still y0. And then it would look like this. And then finally we had that parabola right here, which is a different parabola, y versus x. And we can see that we did it from the origin right there, but that would be a parabola too. Okay. So those are the 3 different equations, 3 different graphs. Don't confuse this one with this one. This is not a trajectory. This is not a picture of the motion. This is y as a function of time. That's a picture of the motion, right? That's because we're plotting position versus position. It's a picture. There's no time in there. If you take a water hose and you squirt it, it is a parabola, right? That shows you the path of the motion. That's their trajectory. Okay, that's it. See, that wasn't too long, was it? 6 seconds, 6 minutes.